Hello, this is our MPU project or CPE 355L project. It is a battery capacity tester and it is used to measure the true capacity of the battery. In our project, we used a AA battery holder, so we will measure sets of batteries and compare it to the datasheet. Here, we have an ever-ready battery to be tested, and its typical capacity is 1,100 milliampere hour based on the datasheet. Now we will insert it. So it is measuring the voltage, the milliampere hour, and the temperature. As you can see, it is 1.02 volts and the milliampere hour is dropping and is getting high while the voltage is dropping, and the ambient temperature is varying from 23 to 24 degrees Celsius. By the way, we are inside the laboratory, so we can stabilize the temperature and we can leave the battery until it reaches the low threshold or the cutoff discharging voltage. It is now measuring 0.99 volts and we will just leave it. Okay, so after we left it for approximately 1 hour, it was already discharged and the milliampere is 644 milliampere hour in 87 minutes, and the voltage is 0.80 volts because we set the threshold voltage or the cutoff voltage in 0.8 volts. So this is the battery and it is the final discharge values.
So for the battery too, we're gonna use a rechargeable battery that is fully charged. So the voltage for a rechargeable battery is 1.2 volts. And based on the spec sheet of this battery, its typical milliampere is 25. 2,500 milliamperes per hour. We are using a 0.1 ohms 5 watts resistor as a load. So we're gonna leave the battery as it discharges for hours. So after several hours, the voltage is now 0.8, which is our set low voltage threshold. And the final value of the capacity is 1,878 milliamperes per hour in 423 minutes. We used a 0.1 ohms 5 watt resistor and the IRF 510 MOSFET and the LM35 for our measurement of the ambient temperature. The typical capacity of this battery is 2,500, but due to several discharge and use of the battery, the state of charge of the battery is decreased.
So for the last battery we will test, it is near the discharging voltage or the cutoff voltage, which you can see it is 0.81 volts and the milliampere hour is getting high at 24.4 degrees Celsius. So we set the threshold to 164 that is the sensor value, and it is equivalent to 0.8. So once it reached 164 or 0.8, it will stop discharging.
163 lower.
Rather, 163 or lower.
Magka-count na siya ng samples.
So now you can see it is now counting the samples at sensor value of 163, and it is now continuing to count until it reaches sample 10 or 10 samples. Okay, so now it is now 10 samples, and as you can see, it fully discharges the battery, in which it is displayed, or it displayed the final discharged values: 0.81 volts, 17 milliampere hour in 1.32 minutes at 24.4 degrees Celsius. So now this is our project in CPE 355L, the battery capacity tester. Lastly, we will discuss the codes of our project.
So for our code, here is the explained calculation of the mAh based on the capacity equation, which is the integral of the current. Here we set the integer, the load threshold voltage, which is 0.8 approximately, and the mAh from the derived equation of the mAh from the capacity equation. It is in double mAh since it has a long count of decimal values. The integer bat pin is thus set analog 0 for voltage measurement, and the pin 8 of the Arduino for FET pin. The others are for integer, sensor value, float, and other given for the equations. So for the if statement here, if the battery boolean is false and the sensor value is less than 100, it will show the battery in equals true. It is initialized upon the insertion of a battery. So if you insert a battery, the sensor value will be greater than 100, and the false battery in will be true. And the FET pin gate will be high. So for this part, if the battery inserted is done based on the sensor value, which is already lower than 20, it will state that the battery in is false. So here is the voltage calculation for battery in, true. So here, if not done, it will continue to count the mAh value based on the mAh voltage sum times the mAh calculated. Lastly, if in the if not done statement, it will always check the sensor value. When it reaches the less than low threshold voltage, it will count the samples by incrementing it. Else, if it is less than if samples is less than 0, it will decrement the samples. So finally, if the samples reach 10, greater than 10, done equals true, and it will print the final image value in minutes. This part shows the incrementing minutes as the program runs. We added a delay so that it won't jump values. And here is the serial print for the serial monitor to see the sensor value. That's how it works.